So hello everyone, welcome to the channel. So in this video I'm going to show you how to use the raster calculator in ArcGIS Pro for spatial analysis. So now let's get started. So the raster calculator is one of the important tools to perform a spatial analysis in ArcGIS Pro. So raster calculator is a very important tool in order to perform a spatial analysis work that involving raster datasets. And using this tool, we can perform multiple mathematical calculations using the raster datasets. And this tool is also very useful in case of subsetting the raster datasets. So in this video, we're going to perform our spatial analysis using raster calculator. So in the table of contents section, first you can able to visualize we have different layers here, starting with the slope raster and LULC raster and a digital elevation model, and last we have our aspect raster. So first let us take a look at the slope raster here. So this is the slope raster for this study region. So you can able to see from this color here, the slope value ranges from 0 to 70 degrees. So all the green areas which indicates it is a flat terrain, and the red areas which indicates the which indicates the undulating terrain in the study region. So you can able to see. And next raster, it is our LULC raster. So in the LULC raster, we have created this LULC raster using the Landsat 8 imagery, where we perform the supervised calculations, the supervised classification. So these are the following classes that is available in the study region. So starting with the open water, so the developed area which indicates the build-up areas, and barren land, and deciduous forest, evergreen forest, mixed forest, scrub, grassland, followed by the woody wetlands and emergent herbaceous wetland. And our fourth raster is our digital elevation model here. So you can able to see from this digital elevation model, that is our DEM data. So the highest elevation it is around 64.21 meters, and the lowest elevation which indicated at around 94.91 meters. So all the red areas which indicates the highest elevations you can able to observe. So this region and this specific regions are the highest elevation in this study region, and followed by last we have our aspect raster. So this is our aspect raster. So let me explain about the aspect raster. So an aspect raster in GIS represents the direction of the steepest slope for each cell in the digital elevation model. So it shows which way the land surface is facing, which is useful in hydrology or solar radiation studies. So for example, in case an aspect values are typically varies in degrees, starting from if it is in 0 degree, it is in north facing, and if it is in 90 degree, it indicates the east facing, and in 180 it indicates south facing, and 270 it's going to indicate the west facing. So it is very useful in case of understanding the sunlight exposure on slopes. For example, for solar panel installation or the vegetation growth, or to determine the water flow direction. So now we're going to classify this aspect raster accordingly. So for that, I'm going to navigate the aspect raster here. I'm going to right click and click this option called symbology. So in the symbology, make sure to select the classify. So once you selected classify, we're going to select the number of classes to be around 10. And now we're going to arrange this. So we're going to arrange this value. For example, I'm going to indicate the -1, which is going to indicate the flat, and 0 to 22.5, it's going to indicate the north direction. So likewise, we're going to enter those values here. So now I have managed to classify our aspect raster here. So you can able to see here. So I have labeled as a -1 as a flat, and 0 to 22.5 as north, and northeast as 22.5 to 67.5. So likewise, we classify this aspect raster here. So now let us go ahead and start using a raster calculator. So for that, we're going to navigate this option called analysis. So here we're going to select this tool called Geoprocessing. So now a window pop up saying Geoprocessing here. So here I'm going to search by raster calculator. So you can enter as a raster calculator to select the raster calculator tool, or you can navigate to this option called toolbox. And in that, we're going to navigate to the spatial analyst tool here. So you're going to select the spatial analyst tool. So once you selected the spatial analyst tool, we're going to navigate to this tool called Map Algebra. And in that, you can able to see a raster calculator tool is available. I'm going to click this. So you can go through the details about this particular tool. So for example, I'm gonna click this option here. So to view the details about this particular tool, so Raster Calculator, it builds and executes a single map algebra expression using Python syntax. So in the Raster Calculator tool, we have two simple columns here. So that is in parameter section. We have two columns. One is rasters and the second column is tools. So in the raster column, we have these are the following raster datasets that is available in our ArcGIS Pro project. So starting with aspect, slope, LULC, and digital elevation model. And in the second column, that is tools, we have the different operators. For example, the different mathematical operators starting with plus, minus, multiplication, and divide. So likewise, there is a different mathematical tools that is available here, or the mathematical operators. So you can able to see. So now using Raster Calculator, we're gonna perform an analysis, a spatial analysis. So to identify the optimal solar panel installation sites for this study region. So to do that, we're gonna use these different rasters and these different mathematical operators. So we are basically looking for flat terrain for solar panel installation, and that have a southward facing aspect, so that way it's like we could put the best solar gain. So problems for the cell, and we also looking for locations that are developed or urbanized areas. So to identify those suitable locations, we're going to use this following set of rasters and this following set of mathematical operators. So we're going to use to perform that analysis. So first we're going to investigate our slope raster here. So I'm going to select my slope raster. So you can able to see this is our slope raster. So right from the 0 to 6.3 degrees, it is you can able to see it is completely flat areas. So these are the ideal areas where we can able to place our solar panel installations. So from 0 to 6 degrees is ideal for placing our solar panel. So it is basically a flat terrain. And if you come towards the southern side of this study region, so you can able to observe there is a red color which indicates the slopey area or undulating terrains. So we're going to avoid those areas, and you can able to see here it's completely flat area. It is a river channel here, so it's completely flat in this in the river channel, and we are not going to place our solar panel here. So we're going to look in these areas. Mostly we're going to select the flat areas. So let me get back to Raster Calculator here. So I'm going to select my slope raster, and I'm going to give it a conditions here, that is slope less than 6 degrees. So for that I'm going to select my less than symbol here. I'm going to double click, and after that I'm going to enter the value here, that is less than 6. And then output raster, choose your file location where you could like to save this file. So I have entered as slope less than 6.tif. So we're going to click save. So once you did that, I'm going to click this option called run. So now we have our result. So based on our condition, we have our result, that is our slope raster, that is less than 6 degrees are indicated in green color. So basically the one which indicates the condition true for our the condition specified is true, and 0 is false. So one which indicates the slope value is less than 6 degree, and condition the 0 which here indicates the slope value greater than or equals to 6. So the green areas which indicates the perfectly flat terrain. So in the next step, we're going to navigate to aspect raster here. So basically we're going to find those locations that have the southward facing aspect. So from the aspect raster, we have our information. So we are going to basically select the southward facing aspects here. So for example, the southeast start from 112.5 and south and southwest. So starting from 112.5 to 247.5 degrees. So basically we're going to select the south facing aspects here, the southeast to southwest. So 112 to 247.5. So now again I'm going to navigate to my geoprocessing section here. So I'm going to remove my previous condition here. So I'm going to select my aspect raster by double click. And once you double click it, so we're gonna mention some conditions here. So aspect greater than 112.5, so we're gonna mention as 112.5. And next we're gonna select another operator, so that is the AND operator. So I'm gonna select my AND operator. I'm gonna double click, and next I'm gonna select again the aspect raster. I'm gonna double click, and I'm gonna select less than so I'm gonna select the less than sign here. So I'm gonna select this less than 247.5. So I'm gonna select this value 247.5. Gonna enter as 247.5. And in the last step, let us add some parentheses to it. So let me navigate to the parentheses here. So, or you can select your parentheses from your keyboard here. So let me enter my parentheses here. So similarly, I'm going to place my parentheses here. And likewise for this aspect too. And last for this, I'm going to close this parenthesis. And last, we're going to save the output raster as the south aspect, the southwards facing aspect. So here I have entered as the southward face aspect. So I'm going to click save. And once you did that, I'm going to click this option called run. And let us visualize the result here. So now we have our result. You can able to visualize this raster here. So this raster has a 0 and 1 value. So the value 1, which indicates the all southward facing aspects. So you can able to see the colors here. These are which indicates the southward facing aspects. So we can just remove this value. So I'm going to right click and I'm going to select no color. So let me turn off other layers here. And I'm going to turn off the aspect here. And in the slope LT, that is less than 6, I'm going to make this particular value as no color. So now we can able to visualize the southward facing aspects are indicated in the purple color. And the slope less than 6 degrees are indicated in the green color. So you can also turn on the stem data here. So let me change the color of this particular raster here. So I'm going to select this particular color. So now you can able to see, I'm going to turn off the slope raster. So you can able to visualize the entire aspect raster, the southward facing aspect rasters. So below we have our SRTM dim here. So this is our southward face aspects here, the southward aspects you can able to see. So in the next step, so we're going to select both the southward face aspect layer and the slope less than 6 degree layer. So to do that, let me navigate to the geoprocessing section here. So this is our geoprocessing tool, so Raster Calculator. So now we're going to remove these conditions here. So next I'm going to select both aspect and the slope less than 6 degrees. So to select the raster aspect, I'm going to navigate to the raster column here. I'm going to click this, double click the aspect raster. And in the aspect south, we're going to select this particular value, that is 1. So which going to represent the southward face aspect. So for that, I'm going to use some mathematical operators. So I'm going to navigate this option here. So I'm going to click this double equal option operator here. So once you did that, I'm going to click 1 here. So I'm going to enter 1. Similarly, so now we're going to use my AND operator. So let me navigate to the AND operator in the tool column here. So I'm going to double click this operator, AND operator. And now I'm going to select the slope less than 6 degree raster. I'm going to double click this particular raster. So next I'm going to select this particular operator, double equal operator, equals to 1. So the one which indicates the slope less than 6 degree raster, which going to represents all the areas, that is a slope value less than 6 degree, which indicates the flat area. So I've selected slope less than 6.if double equals to 1. 1 represents this particular raster value, which indicates the slope less than 6 degrees. And make sure that we add our parenthesis here. So I'm going to add my parenthesis here. Similarly, in the slope raster slope conditions too here. So I'm going to add my parenthesis. So now in the output raster, so I'm going to navigate to my folder location where I would like to save this. So I'm going to mention it as south flat. So mentioned as south flat .if. So we're gonna click save here, and once you did that, we're gonna click this option called run. So the tool is running here, so you can able to see. So the output image, the south flat .tif, it's completely an empty image. So I have made a small mistake here. So instead of selecting the south face aspect and slope less than 6, so I have selected the aspect raster and slope raster. So we're gonna remove this condition, and I'm gonna specify it again using the southward face aspect and slope less than 6 degree. So we're gonna select the southward face aspect. I'm gonna double click this, and I'm gonna select this operator double equals to, and I'm gonna use my AND operator here. So let me select my AND operator, and similarly I'm gonna select my slope less than 6 degree, and I'm gonna use my double equal sign here, and double equals to 1, and I'm gonna close this parenthesis. Using this parenthesis, I'm gonna close this. So now I'm gonna select my output file location. So I'm gonna mention as south flat 5, and I'm gonna run this. Let me click run, and now let us visualize the result here. So now it is correct raster. So I'm gonna remove this particular one. So south flat 5. So this is our required one. So this is our required raster. So the south facing and the slope less than 6 degree. So let me I'm gonna give no color to this value 0, and this is the required layer here. So this is the south aspect and the slope less than 6 degrees. So the next step, we have to select solar panel installation for the optimal sites. So for that, we're going to use our land cover data here. So let me show you that. I'm going to turn this off, and I'm going to show you my this is our land use land cover data. So I've generated using Landsat 8 imagery using supervised classification. So we're going to select all the urban areas, and because we're going to place our solar panel over these urban areas, so we're going to select the urban areas. So we're going to right click here and click this option called attribute table. So you can able to see here the developed which indicates the urban areas. So we're going to select this particular one. It's going to get highlighted, so you can able to see that. You're going to select all this developed together, so you can able to see all these highlighted ones are the urbanized areas, so which is suitable for our solar panel installation based on our previous raster, that is the south face aspect and the slope less than 6 degree aspect. So and also we're gonna select the urban areas. So the urban values in the attribute table ranges from 21 to 24. So I'm gonna note from 21 to 24. These are the values starting from 21 to 24 are the urban areas. So I'm gonna close my attribute table here, and I'm gonna clear my selection, and I'm gonna navigate to the raster calculator again here. So I'm gonna remove the previous conditions here, and now in the map algebra in this I'm gonna express an expression to select all the urban areas using our LULC raster. So I'm gonna double click on this LULC raster. So to select all those urban areas starting from the value 21 to 24, so I'm gonna use my this mathematical operator double equal. So I'm gonna mention my value 21, and I'm gonna use my another mathematical operator. So we're gonna use the OR operator. So I'm gonna select this OR operator, and again I'm gonna select my LULC raster again, and I'm gonna mention the double equal sign here. I'm gonna mention double equal sign, and 2022, that is 2022. So 22. So likewise you're gonna select 21, 22, 23 and 24. So I'm gonna copy this, and I'm gonna paste it here, and similarly I'm gonna paste it here. So here I'm gonna mention as 23, and here I'm gonna mention as 24. So now I have managed to select all the urbanized classes starting from 21, 22 and 23 and 24, and make sure that you give a parenthesis to this. So I'm gonna give my parenthesis, and likewise to others too. And last I'm gonna add the parenthesis for this particular class, that is 24. And once you've added a parenthesis, now we are ready to run this. So choose your output file location. So I'm gonna select this, and name I'm going to give is developed. So the name is developed. So develop.tif. So we're going to click save, and once you did that, we're going to run this code. We're going to run this raster, the raster calculator. So now you can able to visualize. We have managed to select all the urban areas in the study region. You can able to see here. So you can able to see all the green values, which indicates the urban areas. So the blue areas, which that is the green areas, which indicates the urbanized area. So you can able to see that. So in the last condition, we're going to identify the optimal locations for solar panel installation. So we're going to use this developed raster and the south flat. So first let me select the developed raster. So I'm going to select the developed raster here. I'm going to double click, and I'm going to use my double equal operator. I'm going to select this, and I'm going to mention the number here, and similarly I'm going to use my AND operator here. So next I'm going to select this south flat phi.tif. I'm going to select this raster. I'm going to double click, and I'm going to select my double equal operator. So I'm going to select 1 here, double equals to the south flat phi.tif double equals to 1, and make sure that you give a parenthesis to it. And I'm going to give a parenthesis here. So again a parenthesis here, and choose your output file location where you could like to save this. So the name I'm going to give it is the optimal sites here. So in order to identify the optimal sites for the solar panel installation, so I'm going to mention as optimal sites .tif. So once you did that, we're going to click save, and we're going to run this. I'm going to click this option called run. So now we have our final result here. So we're going to deselect all of the layers here, and I'm going to give a no color to this 0 value here. But right click and click this option called no color. So now I'm going to change the color. I'm going to select a red color. So the red areas, which indicates an optimal site for the solar panel installation. And let me change the base map to a satellite imagery. So for the better visualization, I'm going to select my imagery. So now we can clearly able to visualize the areas where we can place our solar panel for optimal sites. So you can able to see here. So you can able to see this is the final result. So we have shown you how to subset the raster dataset, and with an example I've shown you how to identify an optimal site for solar panel installations. So in this video I have shown you how to use a raster calculator in ArcGIS Pro for spatial analysis. So thanks for watching, and make sure that you subscribe to our channel and give us a like.